Hello everyone, myself Kiran Karpuntla, lecturer, Department of Electronics and Communication Engineering. Today we are going to discuss about filters. So first question is what is filters? Okay, generally we know the meaning of filter. For what we use the word filter? Filter means which separates the wanted thing and the unwanted things. Okay, so in electrical or electronic also we use the filter to separate the things which is required and not required. Okay, coming to the statement, an electrical filter is a circuit which can be designed to modify, reshape, or reject all the undesired frequencies of an electrical signal and pass only the desired signals. Okay, so this is the statement. Even we use a filter in a power supply. In a power supply, filters are used to eliminate the ripples and works as a smoothing circuit. It reduces the ripples from the rectifier output voltage. Okay, so normally this is the statement, but when we are using the filter in the communication part, and this is the statement when we are using it in the power supply. Okay, so this is the statement of filters. Next, we will be dealing about the types of filters. Okay, so now we'll see what are the types of filter. So we have various classification. Okay, let's see one by one. So now, depending on the type of element used in their construction, filters are classified into two types. Okay, so it is based on type of element used. So mainly these are two types. One is a passive filter, one more is a active filters. So by the name only, we'll get some idea what is mean by passive filter or what is mean by active filter. Let's see one by one. So first we'll deal about the passive filters. Okay. So what is mean by passive filter? Passive filter is a one which uses the passive element in the filter circuit. Okay. So passive element means those are resistor, capacitor, inductors. Okay. These are the passive components. So if the filter is using these components, we call it as a passive filter. So coming to the concept of passive filter, it does not use any external energy source. Okay. So because of that, there is no any voltage gain in these kind of a filters. Okay, the output voltage is always less than the its input voltage. This is the concept of passive filter. Then next one is a active filter. So an active filter, it make use of the active elements. Okay, active elements such as operational amplifier, transistor, etc. Along with the these resistor and capacitors. Since these are using the active elements and it is taking use of the external power source to use it for the boosting or amplification purpose. Hence the output voltage is always output voltage may be greater than the input voltage. That means it will be having the high voltage gain. So this is about the active filter. So active filter has the advantage of having the higher gain. Passive filter has the advantage of the simplification in the circuit. So based on the requirement, either we can use the passive filter or active filter. Okay. So uh, next classification of filter is depending on the frequency response. So based on the frequency response, we can classify the filters into four categories. One is low pass filter, one is high pass filter, one more is band pass filter, one more is a band elimination filter. These are the four types of filters classified based on the frequency response. Okay, let's see one by one. So first one is a low pass filter. Okay. So low pass filter means what? So normally in the filters in the communication we will be having one cutoff. Okay. So low pass filter is the one which passes the frequencies below this cutoff. Okay. Suppose say the cutoff frequency is 10 kilohertz. If the cutoff frequency is 10 kilohertz, that means this low pass filter is going to allow the frequencies below that 10 kilohertz, 10 kilohertz, and it will eliminate or stops the frequencies above the that 10 kilohertz. Okay, so that is the this is the cutoff. Okay, so you can see here this is called as a pass band and this is called as a stop band. This is called as a pass band because it passes the frequency ranging between 0 to cutoff frequency, and it is called as a stop band because it will stop the or eliminate the frequencies which is above the cutoff frequency fc and till infinity. It will not allow any signal after the cutoff frequency. This is a low pass filter. Okay, so next we have a high pass filter. Okay, so high pass filter, you can see the diagram here. In this, it passes the higher frequencies. Okay, in this also we'll be having the cutoff frequency fc. So frequencies below the cutoff will be stopped or eliminated, and above the cutoff frequency it will be allowed. So here it is called a stop band. It stops the signal, and here it is a pass band which passes the signal. So here, if you want a higher frequency to pass, then we can go for high pass filter. If you want to pass the lower frequency, we can go for a low pass filter. Suppose if you want to pass only certain band of frequencies, okay, because in a low pass it passes from 0 to cutoff, and in high pass it passes cutoff to infinity. Suppose if you want only pass the certain band of a frequency, then we have to use the one more type of filter that is called band pass filter. So in this, it passes the signal in a particular band. Even by the name also you can identify what is the meaning of these filters. So in a low pass filter, it indicates a low pass, means it passes the only lower frequencies. In high pass, so high pass filter, it says high pass means higher frequency will be passed. This is a band pass, means it will passes only band of frequencies. Here we have a facility to choose the band of frequencies to pass. Okay, so in this it will be having the two cutoff frequencies. One is FC1, one is FC2. So this FC1 is called as a lower cutoff and FC2 is called as a higher cutoff. So in this, the frequency ranges from 0 to lower cutoff. That's FC1 will be stopped, and the frequencies from FC1 to FC2 means the frequencies between lower cutoff to the higher cutoff. This range will be passed. Okay, and then this higher cutoff to the infinity. This range will be stopped. So that means it is going to pass only the frequencies between these two cutoff frequencies, okay, FC1 and FC2. So it is used when we want only certain band of frequency to be selected. Example, when we are choosing any radio channels, okay, we choose only particular channels. That is possible because by using the band pass filter. In this band pass filter, we will choose only certain band of frequencies. Only those signal will be available to us. Okay, that is a band pass filter. Suppose think if we don't want only certain band of frequencies, okay, in this case we are using or selecting only certain band of frequencies. Suppose in case we want only to stop the certain band, then we will go for a band elimination filter. So it eliminates the certain band of frequencies. That is a band elimination filter. In this band elimination filter also, we will be having two cutoff frequencies. That is FC1 and FC2. So FC1 is a lower cutoff and FC2 is a higher cutoff. In this, it will passes the signal from 0 to lower cutoff FC1. That is it is pass band, and it will stop the frequencies from FC1 to FC2, that is lower cutoff to higher cutoff. This is a stop band because it won't passes any frequency ranging from FC1 to FC2. Then it will passes the frequency or the passes the signal of frequency FC2 to the infinity. All the signal will be passed. So you can see here it is passing all the signal except this band. Only this band of signals are stopped. So this is called a band elimination. It is useful when we want to reject only the particular band of frequencies. So I hope you understood the different types of filters. That is a low pass filter, high pass filter, band pass filter, and band elimination filter. Okay. So these are the four types of filter based on the frequency of operation. Next, we'll be dealing about the applications of filters. So now we'll understand in what are the applications or where all the filters will be used. Okay, we have various application of a filter. Okay, filter will be used in various applications. Let's see one by one. We'll see here only few applications. In reality, it has so many applications in the electronic circuits. Okay, so coming to the first one, power supply smoothing. So in this, we are dealing about the power supply. So as we are already discussing about the power supply and we are in the same chapter. So we know that in a power supply, in converting from AC to DC, we have various steps. Okay. So in converting AC to DC, first we have transformer, which converts our higher main signal to the lower signal, lower frequency. That is a function of transformer. Then the signal will be AC only with the lesser amplitude. Okay, then it is given to the rectifier. The function of rectifier is to convert your AC to DC. Okay, but it doesn't mean it will give the pure DC. Okay, it will be hung the ripples. So, and we cannot use that directly to the electronic equipments, because and our electronic equipment cannot works on the that pulsating or ripples DC with the ripples. So we have to smoothen it. In that case, we use a filter. The function of this filter is to reduce the ripples present in the output of the rectifier. So it will smoothen and it will pass. That is the application of a filter. Then coming to the next one more application, the tuner in a radio. So as I already told, it is used to select. Okay. So in a tuner, in a radio, okay, in a radio, what we do, we select the particular channel. Okay. What actually what we are doing in that, actually we are selecting the particular frequency. Okay. In that many even now we hear so many FMs. Okay. So all FMs are coming in different frequencies. Okay. Whichever channel we want, we just choose it. Means we are going to tune it or select to the particular channel. Nothing but we are selecting the particular frequency and rejecting all other frequencies. Just you can imagine or you can think which kind of a filter it is using. Okay, just now we discussed about the low pass, high pass, band pass, and band elimination. You can think which filter it will be using. Okay, so can we guess which filter it will be using? Okay, so I hope many of you already got an idea, because we have discussed the all the four. In that, this will be using the band pass filter, because it is using the certain band. If you use only low pass, it will passes all the frequencies below the cutoff. That means you cannot choose only particular channel. Okay. If you use a high pass, it will pass all the frequencies above the cutoff. So even in that also we cannot choose a particular channel. In a band elimination also we cannot get this application. So we can use a band pass filter for the tuner in the radio. Okay. I hope you understood the application of filter in the radio. Next comes as a noise suppression. So noise suppression, what is noise? It's undesired signals. Okay. So in a signal, whatever we receive, it will be having the required signal and not required signal, or desired signal or non-desired signal. So as we already know the meaning of filter, filter chooses only the required signals. Okay. It will catches the desired signal and rejects the unwanted signal. So by that, it is used for the noise suppression. Next, one more example or one more application we can deal, that is a treble and bass of the speaker. Okay. So in a speaker, we have a various kind of a speakers. One uses for the higher frequencies and one will be used for the lower frequencies. One uses for the instrument sounds, one is used for the vocal sounds. Okay. And it will give a very good quality. So now the question arises, how these are separated. Okay. What is a treble? What is a bass? How they are separated? Okay, that is also done by using the filter. So actually all this in a sound or the songs whatever we hear, it will be having the different frequencies. Example, our vocal sound will be having the different frequencies, and instrument what they use will be having the different frequencies. Okay, so higher frequencies and lower frequencies. In the speakers we separate the signal what we receive from the song or any audio. First, we are going to separate the lower frequency and higher frequency. Then we are going to pass it to the treble and bass. That is why we are able to hear the different sounds from the different speakers. So it will give the good quality of audio output, and it won't be having any mixture. So in the home theaters and all, we use this application. So and we have many more application like this of a filters. Okay, these are the only few what we have discussed. So I think you are very much clear about the applications of a filter, where all we use it and how we can use it. Okay, so this is the application of a filter. Next, we discuss about what is the need for a filter in power supply. So why we are using the filter in the power supply? Okay, if we not use it, what happens, and why it is so important to use it in a power supply? Okay, so more or less we already discussed about this in this class. We'll discuss it again in detail. So what is the need? So to understand the need of the filter, first we have to understand the complete power supply sections. So what are the sections it will be including? Okay, power supply including first stage is the transformer, second stage is a rectifier, then third stage is the filter. Okay, so now when we are converting our AC signal to DC, we have various steps. First, from the mains we'll be getting the 230 volts AC. Okay, so we cannot convert directly that 230 volt into DC, because normally in a DC, in a electronic circuit, we won't use the DC of voltage 230. Normally we use a lesser voltages. It may be 5 volt, 12 volt, 24 volt. So lesser voltage. We won't use the 230 volt. So first step is to convert our higher frequency to higher signal to the lower signal. Okay, frequency remains the same, but voltage level will be reduced. So that is a function of a transformer. Once the voltage is reduced, you cannot say it's a DC, because still it is in the form of AC, but the voltage is reduced. Then it is going to the rectifier. It may be a half wave rectifier, full wave rectifier. If it is a half wave rectifier, it will be having only one pulse for the one frequency or one cycle. If it is a full wave, it will be having the two half cycles in the one input cycle. Okay, so in the rectifier, it will convert AC to DC. That means it will remove the negative portion of the signal and it will be passing only positive. So we'll be having the two positive half waves for the one complete cycle. Okay, even now we can call it as a DC because it doesn't have a both the polarities. It's having only signal in the only one polarity. It is called as a DC, but it is not pure since it has a ripples. In many of our power supply will not work on the pulsating or the ripple DC signals. It needs a pure DC. Okay, to operate the electronic circuit, we want a pure DC. For that purpose, we use a filters. So, what is the function of filter? It will remove the AC component or it will reduce the ripples. Okay, that is the main function of filter. So, let's see some important types as important filters. Okay, we have many filters. Those are capacitor filter, even normally we call it as a C filter also. Then we have a pi filter, or even we call it as a CLC filter. Next we have inductor filter or L filter, and one more is a LC filter. So these are the some important filters. These filters are named as per the component used in the design of a filter. Okay, so in the capacitor filter, so it named as a capacitor filter means it will be using the capacitor. Pi filter, it is also called as a CLC filter. Okay, so we'll in this now we will understand why it is called a pi filter or CLC filter. So CLC means it's a capacitor, inductor, and capacitor. Next one more is a inductor filter, means it will be using only inductor. Then LC filter means it will be using a inductor and capacitor. Okay, so these are some important types of filters. In this, the first one capacitor filter and second one pi filter will be discussed here in detail. Okay, so let's go one by one. So first we'll discuss capacitor filter. Okay, so this is the circuit diagram. So this is the input. So this is the DC, but it is a pulsating. You can observe here. We can observe some pulsating signal here. Okay. So in this circuit, we have a capacitor parallel with the load resistor, and this is the load voltage or the output voltage. Okay. So in this, the capacitor is connected across the input voltage that is parallel to the load. So this is the capacitor filter. So here, coming to the function of this capacitor filter, you can before going to this, you should have the idea about the function of capacitor. What is the function of capacitor? What it does? Charges and discharges. Okay, so it is quickly charges based on the capacitor value. So if the value is higher, so in this what happens? It will charges very rapidly and it discharges very slowly. Okay, so that is the property of capacitor used in the capacitor filter. Okay, so let's understand how this ripples will be reduced like this. This is the input to the filter. Okay, actually this is the output of a rectifier in the power supply section, and this is the output of a filter in the power supply section. Okay, so this kind of ripples will be converted into this kind of a waveforms. Okay, we'll understand how it converts this wave to this wave. So this is a half cycle of input. So during the quarter half cycle, in this period, this capacitor charges. Okay, so it is charges rapidly to this quarter voltage, means this maximum voltage. When it reaches to maximum voltage, then the capacitor will be charging to this point. Okay, when it is start discharging, means when the wave comes down or reduces, okay, then it won't discharge immediately because of its property. It will discharge slowly. So this is the line. You can see here it is discharging, but not at this rate. It is discharging very slowly. Okay. As soon as once again the input voltage will reaches or goes above this charge point. In this point, you can see here it is discharging, capacitor discharging, but the input voltage increases or goes above the capacitor voltage. So once again, the capacitor starts charging. So this is the property of a capacitor. Whenever the supply voltage is more, then it start absorbing. Whenever the supply voltage is less or whenever the load is connected, it start discharging. So in this case, whenever the supply voltage goes above the capacitor, it starts once again charging. Once again, after this point, the input voltage decreases, but capacitor discharges very slowly. In this way, the output will be like this. First it will charge, then it will slowly discharge. Once again the input is higher, so it will charge and it will discharge. Once again discharge and discharge. Okay, so by this the output of the filter will be in this form. So you can observe here it is charging, discharging, charging, discharging. By this it will smoothen the signal. Okay, so this is the function of a capacitor filter. Okay, I hope you are very much clear about the concept. Okay, uh, let's see the next one. Okay, okay, next one is a pi filter. It is also called as a CLC filter. So now can you think why it is called as a pi filter? You can see here we have a component C1, C2 and L. In which form they are connected? Is it series, parallel? Okay, actually these are connected in the pi format. Okay, in the pi shape. So that is why it is called as a pi filter. And it having the CLC, okay, capacitor, inductor, capacitor. That is why it is also called as a CLC filter. Okay, this is the pi filter. So now compared to previous filter, that is a capacitor filter, how it differs. Okay, in the previous we had only one capacitor. In this we have a capacitor, then it has an inductor, then it has a capacitor again. So what is the necessity of using these two? Okay, so let's see. So in this, coming to its operation, first the half of this portion up to this point it's similar to your capacitor filter. So first input will be increasing and it will be charging, and when it reaches to the maximum, the capacitor voltage also reaches to that value. When it discharges, start discharging. So after this point, it will start discharging. So output of the capacitor, this capacitor will be like pulsating. Okay. So what we have seen in the earlier capacitor filter. So by using the inductor, once again we are going to smoothen it. So before understanding that, we have to recall what is the function of inductor, how it works. So the property of the inductor is to block AC and passes the DC. So whatever the AC content present in base, it will be stopped by the inductor. Okay. So much of the ripples will be reduced by the C1, and what are the remaining few parts will be removed by the inductor, because it will reduces or block the AC content, and for the DC content it allows to pass. So after the inductor, much of the ripples remaining from the C1 will be reduced. Even after, once again the capacitor used, that is the C2. So in this, so once again it uses the property of its capacitor. What is the property of capacitor? How it works for AC and DC? For DC it will charge when it holds, and AC it will bypasses. So what are the AC content remaining here, that will be bypassed to the ground, and the DC will be stored. Okay, so that means whatever the remaining amount, that will be once again AC amount, AC quantity, that will be passed to ground only. So only DC value will be stored here. Okay, that will be taken to the load because it is connected in parallel across the load. So this DC stored in the capacitor will be taken the load, and much it will be very much pure compared to your capacitor filter, because it's like a, in normal case what we can say is we go for a double filter, triple filter. Okay, so what means by double filter, triple filter, it will be more purified. Okay, compared to single filter, double filter will be having the more purified. Similarly, double filter to triple filter, it will be still more purified in the similar way. So it will be having the more smooth and waveform at the output side. Okay, So I hope you are understood the pipe filter concept and how it is differ from the C filter. Okay. So can you guess which filter is better? So obviously the pipe filter will be better than the C filter. But what is the disadvantage? In this, it needs a more components. In a C filter, we have only one capacitor, but in a pipe filter, we have three components. Okay. So this is the pipe filter. Okay. So it's a time to think, understand, and answer the statements. Okay. So it will shows how much you understood about the question. Okay. So coming to the question bank. So first question is in electronic circuit the role of filter. So in electronics, what is the function of filter? Is it frequency selective circuit, amplitude selective circuit, frequency damping circuit, or amplitude damping circuit? Is it going to damp the frequency or is it going to damp the amplitude? No. The in the definition only we said that it is a selective circuit, means it's going to select. What it is going to select? Is it operating on the amplitude or frequency? So this is a frequency selective network because the filter function is to select the particular frequency. That means the option A is a right answer. It's not going to select the amplitude, even it's not going to damp the frequency or amplitude. So the right answer for this question is option A. Next, move to the option second question. Okay. Second question is in power supply, filter circuit is used. So you may feel that the question is same, but it is different because in the previous question it was asking about the filter in the electronic circuits, but here it is in the particularly power supply. So in a power supply, why it is used? Let's see the options. So first option is the maintain the output voltage constant. Okay. Then next option is reduce the ripples. Third one is a convert AC to DC. And fourth one is a all of the above. Let's see one by one. Maintain the output voltage constant. Is it maintaining the constant voltage? Yes, it is reducing the ripple, but it is not maintaining continuously constant. In future, you will be learning about the regulator. There you will understand what is meaning of the maintaining constant. Okay. Reducing the ripples, is it right? Yes, of course it is reducing the ripples. So this is the right answer. Then converting AC to DC, is it a function of filter? No, because rectifier is doing the converting AC to DC, it is not going to convert it. So this is the wrong answer. So all of the above. Since the A is not correct answer, C is not correct answer, you cannot say all of the above. So right answer is option B, reducing the ripples. Okay. Next, move on to the next question. The passive filter includes. So what is meant by passive filter? We already discussed. So can you guess the answer? So is it, so here four options are given and then four component name is given, then given the option. Think what are the passive filters includes. So it's very easy. Just you have to think what are the passive elements given here. Inductor, is it a passive element? Yes. Transistor, is it a passive element? No. Okay, then capacitor, yes, and op amp, no. That means this 1 and 3, these are having the passive element. That means passive filter includes these two. Let's go with the option. Option A is 1 and 2, means inductor and transistor. Is it correct? No, because the transistor is not a passive element. Next, B option is 2 and 4. So 2 is a transistor, 4 is a op amp. Is it the are they passive elements? No, these are the active elements. So this is not the correct answer. Third option is the first and third, inductor and capacitor. Is it a correct answer? Yes, this is the correct answer. Next option is 3, capacitor. Is it the correct answer? Yes. So, but you cannot say D because in the available options, this is the not only one which is having the passive. Inductor is also a passive. That is why C is the correct answer. Okay. So, answer for this is a inductor and capacitor. Okay. Now dealing with one more question, that is a low pass filter passes dash frequency and high pass filter rejects the dash. So think, so based on the discussion what we had, you can answer this question. And in this, you have to concentrate on the question properly, because one is asking about passing the signal, one more is asking for the rejecting the signal. So you have to think which one is correct. Okay, let's go with the answer. Low pass filter, we discussed what is the function of low pass filter. So low pass filter passes the lower frequencies and rejects the higher frequencies. So low pass filter passes what? Low frequency. Means in the available option, A and B might be correct, because B and D having the high, so it won't passes the high frequency. So remaining option is A and C. Next, and high pass filter rejects. Okay, so high pass filter, what is the function of high pass filter? High pass, it passes only higher frequencies. So passes higher means rejects the lower. So what will be the option in this here? It is the low, because it's asking about the reject, not the select or pass. So high pass filter rejects the low frequencies. That means in both the cases it is the low. It is a low pass filter passes low frequency and high pass filter rejects the low frequency. So which one is correct? Option A. So option is a correct answer for this question. So these are the few questions what we have discussed. And coming to the fifth one, in the following circuit, active filterings. So it's dealing with the active filter, LC filter means inductor and capacitor filter, Z active filter, RC filter means resistor capacitor, third one is op amp, fourth one is a capacitor. So can you answer this? So once again, you have to identify the active element in this, which will give us the answer. L and C, is it an active component? No. That means this is the not a correct option. Then RC filter, R and C, are they both are active? No, both are passive, so it's not the correct answer. C, operational amplifier, is it a passive? No. Is it active? Yes. That means this is going to the correct one. Capacitor input filter, CLC, what we have discussed. In that also, capacitor and inductor both are not active components, so this also wrong. Then the right answer will be op amp. So operational amplifier is the active element. If the filter which is using this op amp is called as a active filter. Okay, so option C is a correct answer. So this is all about the filters. I hope you are understood all the concepts. Okay, go through the video if you want to more clarity. Okay, thank you.